Hey, welcome back. You're watching Centerline Designs. My name's Cole, if you're new to the channel, and we're mainly a custom design and fabrication channel. This is our kickoff project. It's a one-of-a-kind, custom-built aluminum amphibious Snowcat. So what I'm going for here, if you're familiar with what an Argo is, it's like a 6 or 8 wheel amphibious vehicle, drives on land, drives in the water, can pretty much go anywhere you want to go. What a Snowcat is like a trail groomer. You see them out on snowmobile trails or up in the ski hills, and they're meant to make that snow nice and smooth, help winter travel, and they're really cool rigs. I'm trying to take those two ideas and bring them together. It's the first of its kind that I've seen, and I think it's gonna be really cool. We live in an area where there's more water than land, and being amphibious is really important. You're always at risk of falling through the ice, especially in swampy areas or mild winters. So I wanted this amphibious just in case we break through. We're not gonna sink, it will sit there and float, and I'll always be able to have it. I'm not gonna lose it to the bottom of a lake or hopefully not severely get stuck in a swamp. I want to take everyone through a quick overview of what we're building here. I know there's a lot of people that are fairly new to the channel, and I feel that it's probably a good time to review the overall picture because I don't think I've totally explained what I've been doing here in a little while. So let's go over this. So like I said before, this rig is amphibious. My goal is it's going to be watertight to the bottom of the doors. It is powered by a 1.9 liter turbo diesel engine out of the early 2000s Volkswagens, the Jettas. It's a beautiful turbo diesel motor. It's around 90 horsepower, and it's just the perfect size for what we're gonna be doing. We're gonna back this engine up with a set of piston pumps. A piston pump is a positive displacement pump. So these are manual displacement control piston pumps. And there's a little plate inside, and we move this one way or another. It's gonna send fluid through these ports one way or another. And each track is gonna have its own pump. And they do have a common reservoir, so there's a charge pump in here that takes hydraulic fluid from a reservoir, keeps the pumps full, and then each pump is independent of one another, but they run on a common shaft to the engine. So this is a skid steer vehicle. For those of you that aren't used to equipment or anything like that, it basically means we're gonna slow down one track or speed up another to make the vehicle turn one way or the other. What's gonna be really cool about this is the setup I'm doing is gonna be basically true zero turn. If you're, say, on the ice or somewhere like that, where it's not gonna have a lot of friction, you can go one track full forward, one track full reverse, and it'll spin on its central axis. Borrowing the idea from Argo, we're using a bunch of large turf tires to provide the majority of the suspension in this vehicle because there isn't any other kind of traditional suspension. And I know a lot of people comment that it's gonna be a rough ride. Something I've done to combat that is, well, one's fallen down, but we have mechanical suspension seats in here for the driver and the front passenger. So that's gonna help smooth out the ride. But something else to note, this is mainly a winter vehicle. So I'm gonna be driving on snow, hard-packed snow, ice, maybe a little bit of rough terrain. And by doing that, you inherently get a smoother ride. We're not going over boulders and stuff like that consistently. We're gonna be running majority probably down a lake or trails. And by running all of these tires, any pothole or dip, you wind up just skimming right across. It doesn't go into it like a four-wheeled vehicle would. So I think the ride, hopefully, is gonna be better than most people think. In previous videos, you can see me building all of the chassis, putting the body panels on. We have the diesel fuel tank over here. That's its own build video. We have the radiator up here. The engine will be sitting right down in here, and this will all have a big lid that covers it. In the last video, we just went ahead and made the dashboard, which I think turned out really, really well. Inside the vehicle, there's gonna be a pile of storage down around in here. So as I mentioned, this is sort of the engine compartment. That diesel and the hydraulic pumps will be down in here. Out here, we have very large hydraulic wheel motors. And these are meant to take a load of up to like 5,000 pounds. They're meant to be a direct drive on the wheel. And that is gonna be powering the track. So I was originally thinking of trying to go with a drive tire. And I know a lot of people mentioned that probably wouldn't work. I still think it will, but I'm having a problem getting these exact same tires right now. They're all sold out. And I think I'm just gonna go ahead and I'm actually gonna 3D print segmented nylon sprocket. So the big drive sprocket on here, that is gonna drive the tracks. And again, we're gonna be making those tracks ourselves in upcoming videos. That sprocket is probably gonna have about 8 segments, 4 on either side. And we're gonna 3D print that out of nylon. I'm not 100% sure that'll work, but I'm willing to give it a try. Well, I hope that gets those of you that are new to this build up to speed. It was a quick overview of what we're doing here. This isn't a quick, cheap build. I'm putting a lot of time, effort. There's been a lot of design time that's going into this. Not saying everything's gonna be perfect. It is a prototype, but I'm pretty excited with how it's been going. We do plan on getting this engine started quite shortly. The vehicle isn't gonna move, the hydraulic system isn't complete, but I wanna get the engine started. That's gonna be a huge milestone, and then we can work on the other things like the shaft between the engine and the pumps. We can get the wheel motors mounted and the hydraulic lines run for that, and then we need to get making these tracks, which is gonna be an entire labor of love in itself. But I think that's enough for a quick recap, and today we're gonna be getting into some wiring. We need to run about 24, 26 conductors from this back engine bay up to the dashboard we built in the last video. That link will be down in the description below. And then we're gonna start making the main electrical panel that'll be back here. So we have pretty much everything we need to get the majority of the vehicle wiring done. There'll be some specific things due to the engine that will take a little bit more time until it gets back in. But yeah, we're gonna get some wiring done in today's video. So I hope it's not too dry, but it should go pretty well. I have a good plan. As you can see here, I did up, and I think I mentioned it in a previous video, I did up a elementary kind of relay logic wiring diagram. We're gonna have a constant power fuse block and then a fuse block that is powered only when the ignition is on. This is kind of a connection wiring of what the gauge cluster is gonna look like. And I have a lot of electrical bits and pieces, some of which are in the vehicle right now, just sort of mock up. So with the setup here on wiring, I'm gonna have a main panel in the back of the vehicle that will have the positive and negative leads from the battery connect in, go to the starter, the ECU will be there, the fuse blocks will be there, and then we're gonna have probably 26 conductors that run up to the dash panel, and then from there, things can wire out to the end of the line devices like the lights and things like that. So like any custom or prototyping project, you do as much design ahead of time as you can because that's just gonna end up with a better product. But there's often things you can't design ahead of time because you need to get all the components in there and see how they interact with one another. Sure, if I completely 3D modeled this, the engine and everything, I could have figured that out ahead of time, but considering this is a one-off thing, it just doesn't pay to spend the time on the computer doing all that CADing work. So I leave some of these things to be field fit. We're just gonna, I have an idea where I want things to go, but we're just gonna take it slow, look at routings, look at where wiring is gonna go, make sure it doesn't interfere with things. I wouldn't wanna run a main wiring harness over top of the engine area and then not be able to pull the engine and have to disassemble all the wiring. So the things that will stay in place if the engine ever has to come out to be worked on will go under it. And then just the engine component wiring will go on it because those have nice connectors. They can be undone and pulled out of the way real easily. So you'd think it's trivial having to think about things like that, but you really do, because there's so many situations of products you buy these days that just never had that time and effort put into it to think about the guy working on it. And since I'm the guy that's gonna be working on it and I'm the one building it, I don't wanna curse myself down the road. So yeah, taking it slow. Videoing wiring probably isn't gonna be the most entertaining, but we're gonna get a lot done on this video. So again, this is kind of what I'm thinking here. So the engine will be in here, the ECU will be there, we'll have a constant power and an ignition powered fuse block. We've got a circuit breaker there, battery's gonna go here. All of our 26 conductors, well 20 of them will come down under the engine and pump assembly over into this rail, and then they're gonna go down that rail to the front of the cab. So we're gonna use this 2-inch pipe as a conduit, as a raceway to the back. And then we're gonna have to put a hole here and another hole here, and then the cable is gonna have to come out and jump into this tube, in which case it will come right up and enter in behind this dash. So you won't even see that there's wiring in here. 20 conductors are gonna come up this side, 6 conductors are gonna come up that side. Now, I don't actually need 26 conductors going to the front and back. I think I only need about 20 right now, but if you're ever building anything, leave room for expansion. There's area to put more switches in, so let's bring the conductors back up there. It's a good way of connecting the front to the back of the vehicle, and if we want to make any changes in the future, it's gonna be really easy. Yeah, I think it'll work out really well. These are a lot of the engine connectors that I never did actually have to cut, so they're gonna reach really nice to the engine. Again, they'll come over top because if the engine ever has to come out, they just get unplugged. The big 20 conductor cable is gonna come under and then tie into everything here. And the 6 conductor is gonna run in the passenger side rail, as I mentioned earlier. And other than that, all the wiring will happen right here. The battery will sit real close right behind it. And the bulk of the electrical is gonna be really close to one another. So that's really nice. So one of my first thoughts was to put all of it right here. There's gonna be a lid that tips up with some gas shocks, but I figure this area is gonna be a lot nicer to have kind of boxed off, and you can put some extra oil or coolant, ratchet straps, pull ropes, you name it, the things that you need in a vehicle. And the wiring, if I do it well, I shouldn't have to access that much. And if I need to, it will be easy. I'm just gonna have to climb into the vehicle and go over there and look at all the fuses and stuff like that. The battery we'll be able to get at real quick from the back when the lid's open. So again, I'm not burying the battery far away where I can't get at it. It's gonna be literally right here and the lid will open up. So if you need to put a charger on or boost the battery, it's right there, right at the back. Makes sense, right? So I'm just gonna take a little bit more time, lay some of these cables in place, think about it once more, maybe do a test even with this cable going through the tubing to make sure that it will go through it. I mean, 20 conductor cable is pretty large. And yeah, I'll turn the camera back on once we start actually doing something interesting. Watching me think, although, you know, come on, gotta be pretty awesome. I'm sure isn't that entertaining. I'm gonna do a little more figuring and then we'll bring you back in when we finally get to some action. Like I say, we have more water than land around here. That was just a float plane. They're always flying by. I like taking a couple tries at getting it because the depth on this homemade brake of mine isn't the most accurate. So I just like to sneak up on my angle I'm going for, because if you overshoot it, you can fix it, but it's not as nice. I've done it way too many times. I do actually have a 4-foot mechanical press brake just over there. I just don't have any dies for it, and I haven't had time to make any or really source any yet. But that's gonna come in key when we're building the tracks for this. Not bad for a homemade piece of equipment. There we go. There's one end of it. Now let's do the other. Bang on. There, everything will mount on here. Let's go see how it fits. Well, I wanted that flush. Okay, a little trimming's needed. Well, unfortunately, see, I do screw up. I really wanted this space flush with this tubing, and I had taken my measurements, but it's one of those things. I knew it happens, I just wasn't paying attention. When you bend something, I measured it to an exact square corner, but when you bend, you actually shorten the amount of material you need to do it. You kind of cheating it by cutting the corner in a radius. So every time you do that, you're using up less material than you account for, and there's a factor there which I could have subtracted that amount. Instead of a square corner, the radius uses, I think it's 20 thousandths of an inch less material, which doesn't sound like much, but when you start compounding that, it makes things not line up. I just wasn't thinking, didn't do it. Yeah. So let's fix it. I don't really like the overhang. I'd rather have it back of it. So I'm gonna go ahead, trim off this flange and rebend that side. The other thing I did that I should have done differently was I wound up working from two sides inward. What you wanna do is start at one end, bend, and then keep referencing off that and work your way to the other end, so that if you had any extra material, like the machine doesn't consume the material you calculated, you put all that extra to one end that you could likely just trim off to the desired length. But your distances between bends would be correct. I didn't do that. Again, I screwed up twice, because if I had measured off my last bend to the next one, I would have nailed this measurement bang on, and I would have had a slightly longer flange here that I could have just trimmed down. Yeah. Oh well, mistakes happen. I would say I learned from it, but I knew better because I've made these mistakes before. I just wasn't paying attention. So let's go ahead, trim that down, or rebend it. It's gonna pull it back just a little bit, but that'll be all right. I don't feel like scrapping this material just for the sake of that. Perfect. Now it doesn't look like I screwed up as much. Maybe just a little bit. we go. Start laying stuff out, mark the holes, and we'll take it out and get everything drilled and tapped. Yeah, we're well on our way. Well, I'm pretty much thinking this is what this is gonna look like. We have the ECM out of the donor car. We got the 2 fuse blocks I talked about. I got a circuit breaker for one of them. And then we're gonna have a positive and negative terminal strips, terminal blocks that the starter will connect into the alternator, and then battery leads will come off those to the battery. That'll be right here. There we go. Let's get some things mounted to this. The only reason I keep these kind of wire strippers around is because they trim machine screws nicely. It's a good way of using up some of those longer ones that you never seem to use. Well, we're back at it here. Another day for me, and the positive and negative terminal blocks I was talking about showed up in the mail, so that's awesome. We're gonna get these mounted in just like that, and then we're gonna be able to start doing a little bit of wiring here. Yesterday I ended right at going to drill the holes to run the big multi-conductors up to the dashboard. And I was gonna go ahead and try and use a hole saw, and it was looking like it was gonna work out well, except I can't get a hole drilled between these 2 tubes. So I'm gonna go ahead, do some marking out, and then we're gonna notch these holes with the plasma cutter, and I'll just try and clean it up and deburr it as best as possible from there. So this was just one of those times in the project where I wound up having to turn the camera off, get some help from my lovely wife, because this cable was really hard to get up there, so I didn't really film much of it here. Well, that was a lot of struggling, but we got it done. I got the 20 conductor and the 6 conductor that enter in the rails there. and then they come up through here and there, and then they come out on either side up on the top. This behemoth though, that went in 1 inch at a time. It was brutal, but get that back on, we'll have a panel on the inside, it'd be perfect. Next things are to get this cable secured down, and then put the cowling back on, and then we'll start fanning out and terminating the wires at the panel and up at the dash. Well, I got myself all set up here, and we're gonna start terminating some wires. So I'm gonna turn some music on, because this it's one of those things you kind of get in the zone, and maybe we'll do a little time lapse on this and you can kind of see it come together. I don't know. Anyways, let's get to it.
This is just one of those times in a project where all your pre-planning comes in handy. At this point, it's just execute. Strip this cable back, we'll start getting some terminations done, and you can really just enjoy the process of doing the work, because lots of times you're interrupted by filming or such a variety of things, and at this point in time you can really find your zone and get into it. And like always, jamming out to some tunes along the way is just a part of the process. Well, I sure do hope all this works out in the end. I'm putting a lot of blood, sweat, and tears into this, but it's really been a great project to keep my mind busy, and I'm thankful to have a family that thinks it's pretty cool and wants to get it done as well. So yeah, it's really a nice outlet for myself coming and working on this thing.
Well, I ended up turning off the camera there, just the work was getting so repetitive, but here you go. This was a lot of hours put into getting this sort of laid out, and it's almost there. Lots of the other things that need to go to the engine that can't quite go in place yet. So now it's time, we gotta tackle the other end of those wires. Gotta get up there and start terminating all the gauges. There are some extra conductors for things that just aren't in there yet, so we'll tape those up and leave them for future use. Yeah, we're getting there. Alrighty, well, I'm gonna get up on this ladder and do some more terminating. I'll show you a little bit. I don't think it's all that entertaining. And yeah, then we're just keep plugging away. Well, there's really not a lot to it. Gauges are pretty simple. Ignition, and I need some more switches, so all the extra wires are just wrapped up, because I really don't need to get into the cab lights or horn or stuff like that yet. So that pretty much takes care of this. One thing I wanna mention is I made sure not to, like, this is strapped tight because it goes into the frame, but a lot of the wiring that comes to the actual dash panel, I made sure to leave slack, because once this is closed in, you have to pull the dash down to access this. And if the wires are strapped real tight, because I wired it out here, I'm gonna really struggle. So I made sure to leave enough slack that this can pull down. All right, well, I guess it's time to get back to the rear of the vehicle, and we're gonna start tackling the computer wiring. All right. So yeah, this is some of the wiring that we took out of the car. I did go through and identify most of the wires we need to use, and there's quite a few that we just don't need. So those will just get kind of tucked away. And yeah, time to start getting this sorted out. There's a few different power and ground connections, and yeah, we'll get it done. This is kind of my least favorite part of this. The new wiring's great. Scabbing in this old crap. Oh well, we'll try and make it neat. Hopefully. Well, I know this is probably like watching paint dry, but honestly, we're getting really close. I have most of the computer wiring laid out here now. There's a few stragglers like the wire to the wastegate solenoid, the throttle pedal we're gonna wait on right now. I'm just gonna leave it tied in right here so when we fire the engine we can rev it up pretty easily, so that one will get wired later. And I'm just hooking up the OBD2 port right now. I'm gonna mount it right under the computer here real nicely so then we can hook up, and I need to do the immobilizer delete on this. And I think that's about it. Yeah, and then we're just left with a bunch of connectors that will tie into the engine, the fuel pump, the crank speed sensor, things like that. So we're almost there, and that will probably be the most of this video. I was thinking about it, and I'm pretty sure if we leave the wiring on this video, the next video to come out will be the engine getting installed, some of the intake getting completed, and firing it up. So we're very, very close here. So I got a few things left to do. I need to extend some wiring for the mass airflow sensor. And yeah, we're almost there. So hang tight and enjoy the ride. Well, if you're wondering what I was doing here with this green and black wires, it's for the mass airflow sensor, and from the factory, they're a twisted pair. Two wires that are wrapped around each other, and typically you do see that in sensitive sensors. because what twisting does is any interference, electrical noise, and electrical noise, if you don't know, it's not like an audible thing, it's magnetism. The magnetism that electricity creates, the alternator, motors, anything going on does create electrical noise. And in order to keep your signal from getting corrupted, you twist the pairs so that at any point the signal interferes with both wires evenly, and that prevents any of the electrical noise disturbing your signal, because it affects both wires evenly. Whereas if you had just a parallel pair of wires, you could have one that's affected more than the other, and it can skew the sensor's readings. So I went ahead, twisted that because it was done at factory. And now I think all we have to do is pair up a power wire with this, and we can put it in some loom. The loom I'm using for some of these smaller ones is just this. It's not my favorite. It's the cheaper split loom. Just helps keep all the wires together. I did find some really flexible non-split loom, like the plastic stuff. And in areas where we have bigger bundles, I'm gonna go ahead, cover all the wiring in that once we're all said and done. Well, there we have it. It might not have been the most entertaining video as far as visual progress, but a lot of time went into that. All the wiring on the left is everything that needs to go over top of the engine and connect to it, or connect into the fuel tank or radiator. And if that engine ever gets pulled, that wiring on top will just get disconnected and pulled back, and everything vehicle specific stays in the rig. So that'll be really handy if we ever got to pull the engine for some reason. So the goal for next video is to take the back of the cab off. I gotta make that back window a little bit bigger, and then we're gonna put some seam sealer in, get the back of the cab on for good. We'll get the cowling completely mounted, and then once the engine in, it will be in for good. And yeah, next video, I plan on running this engine. There's a little bit more to do with it with the intake, but we'll get that taken care of. It shouldn't take too long. And as always, if you stayed with me this far, I really do appreciate it. It's all the viewers and the encouragement that you give me makes me want to keep going, and really makes my day. So I really do love getting these videos out to you. I hope more and more people come across my build. I'm hoping it'll become a pretty cool series, and there'll be a lot more in the future to come from Centerline Designs. So with that being said, thank you so much, and we'll see you in the next one. Cheers.